In this lesson, we will discuss another new concept in calculus called antiderivatives. Now, you remember in our last class, we constructed the graph of the derivative of a function if the graph of the function is given. Now, if you look at the graph of a function, we know how the graph of the derivative function will look like. Now, in this lesson, we are going to look at the derivative and see if we can construct the function using the derivative. Remember, derivative is the study of change and rate of change. And if you know the change or the rate of change of a function, can you construct the function? Can you add up all those changes to construct the function? In other words, the antiderivative is actually the reverse process, the opposite process of finding the derivative. In other words, if you are given the derivative, can you find the position, the function from the derivative? So, we say f of x is called the antiderivative of f prime x. In other words, f prime x is the derivative of the function f of x. So far, we were using f of x to find the derivative f prime x. In this lesson, we will have f prime x. We will have to use f prime x to find f of x. So, if f prime x is called the derivative of f of x, then f of x is called the antiderivative of f prime x. Now, another way of saying, y is the antiderivative of dy by dx. What does dy by dx stands for? Dy by dx is the derivative of y with respect to x. I want you to understand here, x is the independent variable and y is the dependent variable. And the dependent variable is our function. So, dy by dx is the rate of change of y with respect to x. If you can now add, somehow sum up, you see, the antiderivative is a process of summing all these changes to get your function back. And that is the process of taking the antiderivative. So what is the antiderivative of dy by dx? The antiderivative of dy by dx is the function y. The antiderivative of dp by dt is the function p. In other words, the antiderivative is the dependent variable that can be solved from the given derivative function. That's right. So, in that case, if dx by dt is the derivative of x with respect to t, then x is the antiderivative of dx by dt. So, in this lesson, if we know dx by dt, we will then be able to find x. If we know dy by dx, then we will be able to find y. The antiderivative of a function is called the integral of the function. The integral, or the process of finding the antiderivative, is called integrating the function. Right? The process is called integration. The operation of finding the integral of a function. Now remember, integral of a function is the antiderivative of the derivative function. And the process is called integration. And we use a symbol for this operation. For any mathematical operation, there is a symbol. Is that right? Now, d by dt stands for derivative of the function with respect to t. D by dx stands for derivative of the function with respect to x. Similarly, we have a symbol for integration. Look at this. It is an s which is stretched. If you stretch an s, that is the symbol for integration. In other words, integration is actually the process of summing all the changes, all the rates of changes to get the function back. You see, the derivative, or the process of finding the derivative, is called differentiation. Differentiation is the process of finding the rate of change. Now, in other words, we have to break the function down into small changes. In the opposite process, we add up all these changes to get our function back. In other words, sum of all the derivatives, sum of all the changes. And therefore, the symbol used for the process, the operation of integration, is an elongated S. Now look at this. You read it like this: integral 2 dx. Now this dx is an important factor. Now look at what that stands for. Stands for integrate 2 with respect to x. In other words, this indicates that the independent variable is x. So integral 2 dx stands for integrate 2 with respect to x. Integral p dt stands for integrate the quantity p with respect to t. That's right. Look at this. Integral x squared dx stands for integrate the quantity x squared with respect to x. Alright, once you remember and know the fundamentals, we can now use this to do basic integration. Now, we already said integrating a function is opposite to the process of finding its derivative. Now, for example, d by dx of 2x equal to 2. The derivative of 2x with respect to x is 2. That means if you integrate 2 with respect to x, you must get back 2x. Because the integration is the process of summing all the rates of change to get your original function back. This is your original function, y equal to 2x. If you find the derivative of that with respect to x, you get derivative of 2x with respect to x is 2. If you now integrate this, in other words, sum all those changes with respect to x, you must get 2x. So we say integral of 2x, integral of the quantity, integral of this with respect to x, integral 2x must give you back the original function. Well, you know that the derivative of a constant is 0. Therefore, what is integral of 0? If derivative of a constant is 0, then if you integrate 0, you must get your constant. Is that right? So, integral 0 dx equal to c. Now, that means we are going to have a problem in this process of integration, because remember, the derivative of 2x is 2. The derivative of 2x plus 5 is also 2. So, if you integrate 2, you might get 2x. You could also get 2x plus 2, 2x plus 3, and so on. That constant number will not be seen when you integrate. Why don't you see the constant number when you integrate? Because when you differentiate it, you understand the meaning of differentiated? When you found the derivative of that constant became 0. So that constant will not appear in the derivative, because the derivative of a constant is 0. And so, when you integrate, because of this process, when you integrate a quantity, you will always add a constant to the result. We don't know what the constant is. It may be 2, 0, 1, any number. That's right. So look at this. Derivative of 2x plus c equal to 2. the derivative of 2x equal to 2, the derivative of 2x plus c also equal to 2. So if you integrate this 2, what should you get back? If you integrate this 2, you must get 2x plus c. Now in this case that c is 0, but it may not be 0 in all cases, and therefore we will follow this rule. Integral of 2 dx equal to 2x plus c. When you integrate any quantity, you always add a c to that, a constant to that. Why do you have to do that? Because the derivative of a constant is 0, and therefore when you find the derivative, that c disappears. And when you find the integral, when you do the opposite process, you must get that c from somewhere. So when you do the integration, always add a 0. Integral a dx equal to ax plus c. Look at that. Integral 2 dx is 2x. And of course you've got to add a c. Integral 2 dx is 2x plus c. Similarly, integral 5 dx is 5x plus c. Integral 3 dt is 3t plus c. In general, integral a dx is ax plus c, an important result. Integral v dt, here v is a constant, it's a number, is vt plus c. This time the independent variable is t. Integral v dt is vt plus c. Alright, remember, the process of integration is opposite to the process of finding the derivative. In other words, if you integrate the derivative, you must get your original function. So tell me, derivative of sine x with respect to x is cosine x. And therefore, if you find the integral of cos x with respect to x, what should you get? If you integrate cosine x with respect to x, you must get sine x. Well, and also you need to add a constant. Why? Because the derivative of sine x plus 5 is cos x. The derivative of sine x plus 10 is also cos x. So we don't know whether in the original function there is a constant or not. To make sure that we don't make a mistake, when you integrate, always add a constant. So integrating cos x with respect to x will give you sine x plus c. These are results you need to remember. Integral a dx is ax plus c. Integral v dt is vt plus c. Integral cos x dx is sine x plus c. Alright, let's do a couple more. The derivative of cos x with respect to x is negative sine x. Is that right? And therefore tell me, if you integrate sine x with respect to x, what will be the result? Well, integral of sine x dx is negative cos x plus c. Because the derivative of cos x is negative sine x, the integral of sine x will be negative cos x plus c. The derivative of tan x with respect to x is secant squared x. Therefore, if you integrate secant squared x, you must get tan x plus c. Always remember, when you integrate a quantity, add a c to it, add a constant to it. And these are some of the basic integration rules that we will be using as we move on. Alright, we have